All right. Got to have some introductory music. Woohoo! All right. Let's talk about the cloudcoder part of exam 2. So we'll go through each of these and see how to solve them. So this first, oh, damn it, the reset button. Okay, there we go. Good. Count number of positives that are less than n. So if we look at the examples here, we want to find the number of positives that are less than n. So this is our array. This is n. We want the number that are both positive, so greater than 0, but also less than n. And as you can see here, this is 4, so 1, 2, 3, 4. 5 is equal to 5, but we're not counting 5, so it's strictly less than n. So this is a counting problem. That means I need a count. It's an array problem, so I need a for loop. Array.length, I++. Good. Now we want to know if array of I is positive and array of I is less than n. If that's the case, add 1 to count. And then we want to return count at the end. I think this will work. Good. Good. That totally worked. For some of these test cases, you'll notice you can't see the inputs and the outputs. Those are marked as secret tests. We do that in cloudcoder, especially for things we use for exams. We don't want students, this never happened before, but it could happen where students just sort of write the code to like check if it's this case, if so, put out 4. Check if it's this case, if so, put out 0. Like not actually write the code at all, but just match all the inputs to the expected output. So we have at least one in there where you don't know what the expected input and output is. So that's the first one. And I think, yeah, there we go. Okay. Count number of positives less than n. Let's try this one. Same number of positive, -2. So want an array of ints and return true if the array has the same number of positive and negative values, and 0 is neither positive nor negative, so 0s you don't really care about. Okay, so we're basically going through the loop. We're counting 2 things. I'm going to do this 2 different ways. I'm going to say int positive equals 0, int negative equals 0. Now I'm going to say I equals 0, I less than array.length, I++. And I'm going to say if array of I greater than 0, positive ++, if array of I less than 0, negative ++. And so then at the end of that for loop, positive and negative will have the number of positive and negative values in the array. I can actually return positive equal negative. Because remember, I need to return a Boolean. Positive equal negative is either true or false. Well, if it's true, that's exactly when we want to return true, when the number of positives equals the number of negatives. If it's not true, then we want to return false, which is fine. That's when positives does not equal negatives. Let's see if this works. Oh, it totally worked. That's fantastic. Let me show you another way to do this now. I can actually just do this with 1 counter. This is going to be so freaking cool. I'm really excited about this. So watch this. If positive is greater than 0, add 1 to the count. Otherwise, if positive is less than 0, subtract 1 from the count. So if there have been the same number of positives as negatives, count should be 0. I bet this will work. Oh my gosh, that's so cool. Right, because if we see a positive, add 1 to count. If we see a negative, subtract 1 from count. If this is 0, that means that every time we did this, we also did this some other time. If this is negative, that means we had more negatives than positives, and if count is positive, that means we had more positives than negatives. So this is just sort of another way to do this. You don't have to do it this way. You can do it the first way too. It just totally depends. Good. So that's fun. What do we got? Exam 2. Oh wait, I should probably, let me start closing things up. Let's get the link from here. Here we go. Whoops. Right, 2D max. Okay, good. This is a good one. This will be a great one. Okay, so we want a function that takes a 2D int array and finds the max in each of the arrays, so the max of everything. Some of the arrays might be empty, but you can assume that none of them are null. So for example, if we look at these arrays, the max here is 3, the max there is 6, max 7, max 4. The overall max is 7. So we're just finding the overall max of everything. So, and if we can assume that none of the arrays are null, that means that what we can do is we could say max, we're going to initialize it to array 0 of 0. So basically, the first array, the first element, whatever that happens to be, that's, before we even start looking, that's the biggest thing we've seen so far. Now we'll do int I equals 0, I less than array.length, I plus plus. Now we need another loop. We'll need for int j equals 0, j less than array of, not of 0, array of I dot length, j plus plus. And so what we want here is if array of I of j is greater than max, then max equal array of I of j. And then at the very end here, we will return max. So what's going on here? We're initializing max to the first column of the first row, you can think of it as the first element of the first array. So array of 0 is this whole array, because array is a 2D array, and then array of 0 would be this very first element. We know that none of the arrays are null. And then if that, then we just have a loop. This loop is counting rows, this loop is counting columns. If something's bigger than max, then that's the new max, then we return max. Let's see if this works. It might not. Nope, it totally works. So we know, yeah, and then there's the one test case that you can't see what the inputs and outputs are. I'm looking through these test cases to see if anything, yeah, this one actually has an empty array in it, but that's okay. If one of the arrays is empty, we'll start j out at 0, but if array of I.length is itself 0, well 0 is not less than 0, so the loop won't even run at all. Yeah, so we're just finding the overall max of everything that's in there, but we have to do it one row, one array at a time in order to get that to work. Good, I'll go ahead and close that up, go back to here. No duplicates. Okay, so write a function that takes two arrays of ints and returns true if the arrays do not contain duplicate elements and false otherwise. Okay, so let's think what this is asking me to do. I've got an array, and nothing here occurs over here. But here, one of these elements occurs over here, and then here you get a bunch of things, and nothing occurs over there because it's empty. Okay, I think I see what's going on here. There's a couple ways to do this. We know there's no duplicates if for each element in the first array, we check the second array and we don't see it. So we start with 1, we check everything in the second array. If we see anything equal to 1, then we can immediately return false. We found one duplicate. But if we look in the second array and we don't see anything that's equal to 1, we can't return true yet. We have to go on to the next element. So we go on to 2. Now we check everything. If anything's equal to 2, we return false. Otherwise, go on to the next element, check everything. And then now that we're done with the first array, we've checked everything in the first array, each element one at a time against everything in the second array. If we haven't seen any duplicates, well, we can just go ahead and return true. So let's do it this way. For int I equals 0, I less than array 1.length, I plus plus. Now we'll do this. For int j equals 0, j less than array 2.length, j plus plus. If array 1 of I equal array 2 of j, immediately return false. And then at the bottom of all this, return true. Right? What is that? Is that correct? Return true if they don't contain duplicate elements. Yep, that totally makes sense. So what's happening here, this first loop is counting out each element of array 1. So I is initially 0. J is now going to go through everything that's in array 2. And if we ever see I, which is 0, equal to, not I, but the array element at index I in array 1, equal to the thing in array 2 at position J, J is going to go through everything, then we can return false. And if that never happens, we go on and I becomes 1, we do it again, so on and so forth. And if we never return false ever, then we can go ahead and return true. I think this works. Oh man, look at that. I'm totally awesome. Cool. Oh, I guess I didn't mark any of these as private. I guess you can see all the test cases. Well, good times. One thing you'll probably note, I don't quite know what to do about this, other than just that we go and look at all the code in addition to just the outcomes. But for things that return true or false, the test cases are usually split 50-50, but sometimes they're not. So you could just literally put, watch this. This is bizarre. Look at that. I just returned true. I got half the test cases right just by returning true, because half the test cases tend, return true. If it's true or false, only 2 choices. Don't do that, by the way, but just it's amusing to note that you could. Okay, no duplicates. Now, longest in-order subsequence. So I've got my solution here. This works. I'll go ahead and reset it, though, and see if I can rederive it. This is embarrassing. I might not be able to rederive it, but we'll see how it goes. Sorry, I can rederive it, but my solution, in the back of my mind when I was looking at this in class today, I think I may have done it in a more complicated way than necessary. But I don't know. Let's see. So we're looking for the longest in-order subsequence. Now let's think about what this means. An in-order subsequence, as it's defined up here, actually, you know what? I can move this over. Oh, look at that. That's way better. Good. Perfect. So given an array of ints, return the length of the longest sequence of ints that is in order and differ by 1. So 1, 2, 3 adds 1 in-order subsequence of size 3, right? Because you've got 3 numbers in a row. They all differ by 1. So that's an in-order subsequence of size 3. 1, 3, 5, that's 3 different in-order sequences of size 1, right? Because 1 and 3 don't differ by 1, so that's just a 1, a 1, and a 1. And then over here, oh, I'm recording. Somebody's knocking on the door. We got 1, 2, and 4. So, right, this is an in-order subsequence of size 2, and then this is another one of 1. So the longest one in here is of size 2. So, and then of course if it's an empty array, we should just return 0 since there's no sequences at all. So that's actually an easy case. So if nums.length is 0, let's just return 0, right? Because if it's empty, then there's no sequences at all, so we can just return 0. Otherwise, let's do this. The best is 1. And now, I think what we're going to do is we're going to write a loop. We're going to pick a number and then start looking at everything after it and seeing how many things differ by 1. And then, depending on how many things differ by 1, each time we see something that differs by 1, we'll add 1 to our local sequence. And anytime we see something longer than best, that best becomes, we update best. And then as soon as we see something that doesn't fit the pattern, we break the inner loop and then bump the outer loop ahead by 1. Now we could bump it ahead by more than 1. We're going to be repeating a lot of work here, but I don't know. Let's just try this out. So for int I equals 0, I less than nums.length, I plus plus. And so int, the local sequence is 1, I guess. Let's try this. For int j equal, let's start at I plus 1, j less than nums.length, j plus plus. So we're starting sort of 1 after I, and then what we'll do is we'll say if nums of j equal nums of j minus 1 plus 1, right? So if the thing at position j is equal to the thing one before it plus 1, then we want to add 1 to sequence. Now I think, does this mean sequence should start at 1 or should it start at 0? Yep, it should start at 1. We add 1 to sequence, and then inside here, if sequence ever becomes greater than best, well then best equals sequence. So sequence starts at 1 because as soon as you know there's more than 0 things, then any one element is 1 in a row. Once you see something that's 2 in a row, then that's the new best. But here what we can do to save us from doing extra work, as soon as we see something that breaks this pattern, then what we can do is actually just break the whole thing. So that'll break this inner loop and bring back us up here to the outer loop. And then I think at the bottom we just return best. I don't know, let's see if that works. Holy crap, I got it in the first try. The code I had before, I had to put a bunch of print statements in there. Interesting. So, yeah. Well, anyway, so yeah, what we're doing, we're starting I out, so I is, 0, then we're starting at the thing after it, and we're like, well, how many in a row can we get where they all differ by 1? In other words, where the thing at j, the value there, is equal to the value of the one before it plus 1. So if nums of j is, 3, then nums of j minus 1 should be 2 plus 1 would be 3. So that lets us know they differ by 1. Increase our sequence by 1, and if we ever see a sequence greater than our best, that's our new best. Otherwise, we can break as soon as we see that this isn't true, because once we know like 1, 2 are in order, but then 2, 4 are not in order. Well, if 2, 4 are not in order, our best sequence is already done. We can't keep looking at the rest of it. Why bother? It's already not an in-order subsequence. We have to stop and then sort of start over. Now, this part here, this inner loop, is actually a little bit inefficient, because if you think about it, once we count these 3 in a row and then see that this one doesn't fit, I goes to here, and we're going to sort of count a subsequence of this. We actually could want to sort of like reset I to start up there, but we don't have to. There's nothing in here about having to do this efficiently, so we're not actually going to worry about it. Cool. So that's what we've got for those problems from the second exam. I think that's all of them. What is going on here? How come this isn't right? Oh, right. You know why? Because my last run was the one where I just went and returned true to show that, you can like just return true for anything that's Boolean. You'll probably get half of them right because the test cases are about 50-50. Cool. Okay. I guess that's all I've got. Let me post this. Thank you for listening. Good luck on your final.